Good day! So, here I am going to demonstrate the molecular modeling kit that I have built that is specially designed for the visually impaired. So in order to make this a little bit more real, at least for myself and for describing it, I'm going to visually impair myself. I could do that by just simply taking my glasses off, which I can, but if I wanted to read something, all I have to do is hold it up like this and I can read it. So I can still see enough that it's not enough. So, now that I am successfully visually impaired, I'm going to start by preparing my kit for use. So I've got my box of bonds and hydrogens, my box of carbons and sulfurs and oxygens, and carbons and nitrogens over here. So first step is I'm going to build a peptide bond. So it starts with carbon, a nitrogen, and an oxygen. So the carbon is doubly bonded to an oxygen, and then bonded singly to the nitrogen, I'm sorry. So here we have a peptide bond. So this is the part between the two amino acids. So on each side of the peptide bond, is joined an alpha carbon. And then on this side, so each amino acid in itself has a nitrogen, an alpha carbon, then the carbonyl. That's how an amino acid looks. When it's joined, it becomes a peptide bond, which eliminates one of the hydrogens, forming this bond. So ignore this part, and this part is an amino acid, of course, with hydrogens on the nitrogen, and this is called the N-terminus. So I'm going to start with building the first, most simplest amino acid. So each amino acid, alpha carbon, has this hydrogen, and then for glycine it is simply another hydrogen. So this is glycine. Then we have peptide bond. So then connected to this next nitrogen is the alpha carbon of the next amino acid. And again, this is not stereochemically correct, so don't worry about the confirmation. So here's the alpha carbon of the next amino acid. Alright, so here's our broken nitrogen. Pretend there's a nitrogen between these two bonds. So here's our alpha carbon, which is then singly bonded to the carbonyl group. Which, for the C-terminus of the amino acid, is a carboxylic acid. So it has a carbon that is double bonded to an oxygen and singly bonded to an oxygen, which this is like a resonance structure. So there's actually the double bond can be between either one of the carbons, or between either one of the carbons and oxygens, but typically it's represented as here and here. But just because of this kit, we're not able to do it that way. So this is going to be alanine. So as I mentioned, all amino acids, the alpha carbon has one hydrogen, and then the other free bond, bonds to the R group, whatever the R group is. As splicing is simply one hydrogen. Alanine is CH3 group. So I'm going to build that CH3 before I stick it up. So here's our CH3. Here's our alanine alpha carbon. And ta-da, we have an amino acid. And then these two would be joined here by a nitrogen that broke. Not sure what the piece went. So voila. This is a polypeptide, 2 peptides, 2 amino acids, dipeptide. Let's see how I did. Alright, so yeah, so this is what it looks like, roughly. Ta-da! Peptide. Here's our N-terminus over here, C-terminus over here, and peptide. Alright, so just to demonstrate the texturizing that I added to this kit to make it able to discern between sulfur and an oxygen, I'm going to build methionine. So again, I'm going to start with we'll start with the alpha carbon, which always has one hydrogen. And in this case, I'm just going to build an amino acid, not a whole peptide. That on later. So here we have our alpha carbon and our carbonyl carbon. Double bond to oxygen. Oxygen as well. So now to build the side chain of the thionine molecule. Let's put that oxygen back on. Oh, the whole, okay. There's an oxygen on here also. So the side chain of methionine does contain a sulfur atom. It contains carbon, two hydrogens, another carbon, also two hydrogens. So we're occupying all of the bonds here. then in thionine we have a sulfur atom. Now, in a traditional molecular modeling kit, I would not be able to tell the difference between a sulfur and an oxygen because they would be the same size and the same shape and they would both be smooth. But in this case, there's texture, so I can tell that this is a sulfur because it has little dots. And then the final atom on the side chain of thionine is a CH3. Alright, so we have our thionine completed side chain. Then for the carboxy terminal part, I'll try to put another oxygen on here. So we have our carbonyl carboxy terminus, alpha carbon, hydrogen, side chain, and N-terminal side, and then H2. Or in this case, just an H. So let's check my handiwork here. Alright, so we have our side chain, CH3, CH3, sulfur, CH2, CH2, alpha carbon, carboxy terminus, and the pesky N-terminus. Remember. You can see the whole thing now. Ta-da! And my dog's at the door, so I'm gonna go get her. Say hi to everyone! Say hi, Claire!